Good morning, everyone. I'm Esmeraldine Bitoclo, BSED 1E Science. Today, we will having a teaching demonstration. The main objective of this demonstration at the end of the lesson, the pupils must be identify the four layers of the earth and to give the importance of the four layers of the earth. Before we start our topic, we will have a review. So if you remember, our topic from the last meeting is the atmosphere. It is all about the layers of the atmosphere. Moving on, you were informed that we will be going on a journey to the center of the earth and ask you to prepare these things to bring. First, a map, a flashlight with extra batteries, food and a lot of water, extra cloths that do not burn easily, and extra courage for today's journey. Traveling our way to the center of the earth, let's now bring out our map provided by your teacher. And I will tell first what will we encounter during this journey. First, there is the crust, the mantle, the outer core, and the inner core. Going to our first stop, which is the crust. Crust is the layer of the earth where we can live and survive. This is the earth's outermost surface and is relatively light and brittle. The crust of the earth is broken into many pieces called tectonic plates, also called lithospheric plate, a massive irregular shaped slab of rocks generally composed of both continental and oceanic lithosphere. And when these plates collide with each other, it is where earthquakes occur. The crust makes up 1% of the Earth, typically about 25 miles thick beneath continents and about 6.5 miles thick beneath oceans. The Earth's crust is like the skin of an apple. It is very thin compared to the other three layers. And there are two types of crust, and these are the oceanic plate and continental plate. Oceanic plate are plates that are located beneath the ocean and is denser than the continental plate. It is because they are made of denser rocks such as basalt. Second is continental plate. This is a large, solid, and relatively thick tectonic plate that makes up the Earth's continents. These plates can be several hundred kilometers thick and can cover massive areas of the Earth's surface.
Okay, so let's move on to our next destination, where is the mantle. Mantle is the layer below the crust. The mantle is the largest layer of the earth. The mantle is divided into two regions, which are the upper and the lower sections. So, upper mantle is the layer of the earth interior located between the crust and the lower mantle. It consists of solid rock and extends to a depth of about 410 kilometers beneath the Earth's surface. And then second is the lower mantle. Lower mantle is the very thick layer. And then molten rocks are fluid and moving in a circular motion called the convection current. So, lower mantle is the region of Earth interior located beneath the upper mantle, extending from about 410 kilometers to 2,890 kilometers below the Earth's surface. It is composed of solid rock and plays a crucial role in the dynamics of Earth interior and the movement of tectonic plates.
Okay, we already done to our two destinations, which is the Earth's crust and the Earth's mantle. And now we will go now to the deepest part of the Earth, which is the core. Beneath the mantle is the core. The outer core contains iron. When it flows, it generates a magnetic field. When we say magnetic field, it is the region around the magnetic material or a moving electric charge within which is the force of magnetism acts. The Earth's core consists of a fluid outer core that's mostly made of iron and nickel. It's mostly hot and a solid inner core is mostly hot and a dense ball of iron. And the core was the source of the Earth's magnetic field. So we will tackle the outer core first. The outer core of the Earth is made up of liquid metals. The outer core has a very low viscosity, meaning it is very easily to deform and malleable. And now, as we proceed to the inner core of the Earth has a temperature and pressure where the metals are squeezed together and are not able to move. The inner core is solid. The temperature of the inner core is far above the melting point of iron. However, unlike the outer core, the inner core is in an intense pressure. The entire rest of the planet and its atmosphere prevents the iron from melting. The pressure and the density are simply too great for the iron atoms to move into a liquid state. Because this is an unusual set of circumstances, some geophysicists prefer to interpret the inner core not as a solid but a plasma. The liquid outer core separates the inner core from the rest of the Earth, and as a result, the inner core rotates a little differently than the rest of the planet. It rotates eastward, like the surface, but is a little faster, making an extra rotation about 1,000 years. Geoscientists think the iron crystal in the inner core are arranged in a hexagonal closed pack pattern. The crystal align north-south along with the Earth's axis of rotation and magnetic field. The orientation of the crystal structure means seismic waves.
Scientists are able to understand Earth's interior by studying seismic waves. These are waves of energy that travel through Earth, and they move similarly to other types of waves, like sound waves, light waves, and water waves. The movements of the layers lead to natural phenomena such as earthquakes, volcanic activity, and the creation of mountain ranges. Understanding the Earth's outer core and mantle layers plays a crucial role in monitoring volcanoes and predicting earthquakes. For the real-world applications of understanding the Earth's layers in fields like geology, mining, and petroleum exploration, geologists also play an important role in the advancement of alternative energies by studying and searching for minerals to be used in batteries and solar panels, finding and harnessing geothermal, tidal, and hydroelectric power, and more. And this is the end of our discussion. Activities will be provided as assignments, and for the next topic, do a research about biomes and what are their importance. That's all. See you next meeting.